Weeks ago, a small team at NASA's Jet Propulsion Laboratory sent a command out into the dark. Not toward a planet, not toward a moon, toward a single aging spacecraft, nearly 13 billion miles from Earth, that most of the world has already stopped thinking about. They didn't know if it would work. They wouldn't know for the better part of 2 days. Because at that distance, even a yes takes about a day and a half to come home. The spacecraft is Voyager 2. It launched in 1977 alongside its twin, Voyager 1. Both were supposed to last 5 years. Both are now closing in on 50. And on August 4th, 2026, NASA confirmed something most people missed entirely. The fix worked. They bought Voyager 2 more time. But here's what nobody's really asking. Why do two nearly 50-year-old machines running on less power than your kitchen stove light still matter enough that a team of engineers is risking them to keep them alive? To answer that, you have to understand 3 things. What almost killed Voyager 1 3 years ago, what it's still telling us that nothing else can, and what's coming in exactly 3 months from now, a date NASA has already calculated down to the second. Here's the plain version of what actually happened, without the drama. Voyager 1 and Voyager 2 run on radioisotope thermoelectric generators, RTGs, chunks of decaying plutonium generating heat converted into electricity. They've been losing about 4 watts of power every single year since 1977. There's no fixing that. There's no refueling a spacecraft billions of miles away. Every watt lost is gone for good. So the mission team has spent the last 2 years doing something brutal, deciding, instrument by instrument, what to switch off to keep the rest alive. Of the 10 science instruments each Voyager originally carried, both spacecraft are now down to just 2 or 3 still running. This year, engineers tried something different, a power-saving procedure they nicknamed the Big Bang. The idea? Swap out several power-hungry components at once, replace some with lower-draw alternatives, and free up enough wattage to delay the next forced shutdown. They tested it first on Voyager 2 in May and June, because it's closer to Earth and has slightly more power margin, the safer twin to risk. And on August 4th, NASA confirmed it worked. Voyager 2 just bought itself roughly another year before its next instrument has to go dark. Voyager 1 is next, nearly 16 billion miles from Earth. Sometime in the coming months, the team will attempt the same maneuver on the spacecraft that's farther away, harder to reach, and running on even less power. So, a real engineering fix on 2 real, nearly 50-year-old machines. That's the news. But an engineering footnote doesn't explain why people who've never worked at NASA still check in on this mission. For that, you have to go back to the moment this machine almost went silent for good. November 14th, 2023. Voyager 1 is still transmitting. The signal's there, strong as ever, but nothing in it makes sense. Just noise, gibberish. For the first time in 46 years, the most distant thing humanity has ever built has stopped being able to talk to us. Not gone, just unintelligible. The team at JPL doesn't panic. They've kept this mission alive for decades by never panicking. But they also don't have any fast options. Every single test they run has to travel 15 billion miles to reach the spacecraft. Then another 15 billion miles for the answer to come back. Call it out, wait a day, get a partial answer, call again, for 5 straight months. By March, they finally isolate it. A single memory chip inside one of Voyager's 3 onboard computers has failed, worn out, 46 years old, and it just gave out. About 3% of that computer's memory, corrupted, unusable, unfixable, because there's no way to reach in and replace a physical chip on a machine that far from home. So the engineers do something that's less like a repair and more like surgery. They can't fix the chip, so they take the code that was living there and split it into pieces, because no single free block of memory was big enough to hold it all, and tuck those pieces into scraps of space wherever they can find room. Some of that room came from deleting 45-year-old code left over from Voyager's 1979 flyby of Jupiter, programs nobody needed anymore, finally cleared out to make space for the fix. They sent the first piece of the relocated code on April 18, 2024, waited 22.5 hours for it to arrive, waited again for the reply. On April 20th, Voyager 1 spoke again, readable, whole, alive. That's not a machine quietly fading into retirement. That's a team of people who refuse to let it go, doing something that had never been attempted before, on hardware older than most of them. Which raises the real question. If keeping this thing alive takes that much risk, that much effort, what is it actually giving us in return that's worth all of that? For decades, scientists built models of what interstellar space, the space between stars, should look like. Quiet, thin, mostly empty, a cosmic hallway between rooms. Starting in 2017, Voyager 1's plasma wave instrument picked up something those models never predicted. A faint, narrow, persistent signal in the plasma around it. Not a one-time event, a signal that kept showing up year after year across roughly 930 million miles of interstellar space, 10 times the distance from the Earth to the Sun. Researchers published the finding in the journal Nature Astronomy, and what they found wasn't just an oddity. It was the first continuous, steadily sampled measurement of interstellar plasma density anyone has ever recorded. Before this, scientists could only catch scattered snapshots, moments triggered by solar shocks rippling outward and slamming into the interstellar medium, isolated data points, like trying to describe a whole ocean from a handful of photographs taken years apart. What Voyager 1 has been quietly building instead is something closer to a continuous feed. And it shows interstellar space isn't the smooth, empty hallway the models described. It has texture, fluctuation, structure at scales researchers are still working to fully explain. There are two competing explanations for what's actually causing this signal, and right now, nobody knows for certain which one is correct. One version fits comfortably inside existing physics. The other would mean rewriting some of what we think we know about the space between stars. No other instrument has ever measured this directly, because no other instrument has ever been out there long enough or far enough to try. And here's the part that should sit with you. There is no mission currently funded to replace this. If a new interstellar probe were greenlit and launched today, it wouldn't reach this same boundary for at least 25 years. Voyager 1 isn't a nostalgia project. It's the only live source of this particular kind of information humanity has. Which is exactly why every extra year the Big Bang procedure buys it actually matters. Every year is more data nothing else on Earth can currently collect. So how much longer does that window stay open? There's one date already locked onto the calendar that tells you exactly how strange this window is about to get. November 18th, 2026. 2:16 and 07 seconds in the morning Pacific time. NASA has calculated this down to the second. At that exact moment, Voyager 1 will be 16,094,799,096 miles from Earth, the distance light itself travels in a full 24 hours. One light day. It will be the first human-made object in history to reach that distance. Here's what that actually means for the people running this mission. Right now, a command already takes about 23 hours each way. After November 18th, it's a clean 24. And every day after that, it only grows. Susie Dodd has been Voyager's project manager since 2010. She put it about as plainly as it can be put. If she sends a command and says, "Good morning, Voyager 1," at 8 a.m. on a Monday, she gets Voyager's response back at approximately 8 a.m. on Wednesday. That's not a future problem. That's 3 months from today. So here's where this actually leaves us. A spacecraft that was supposed to retire in 1982 is still transmitting in 2026, still the only source of a measurement no other instrument has ever made, still being fought for by a team that just spent 2 years engineering a way to buy it 1 more year of life. Voyager 1 is still out there right now, moving roughly 38,000 miles an hour deeper into the dark, carrying a golden record of human sounds that will likely outlast every one of us and everything we've ever built. If you want to keep following what happens to it, what NASA finds next, and whether Voyager 1's own Big Bang attempt succeeds in the coming months, that's exactly what this channel is for. There's still no answer for what's actually causing that signal out there. When researchers figure it out, this is where you'll hear it first. Subscribe, and I'll see you in the next one.